I'm Tom Kramer. This is part 2, going over Donkey framework, kind of showing you a little bit about how it's put together. In part 1, in a previous video, I went over the basic concepts of parts, how they have different inputs and outputs, how you can name those inputs and outputs, and have parts work together. So in this video, I'm going to go over manage.py in more detail. Actually, we didn't talk about it at all last time, but manage.py is what is created in your user directory. By default, if you use the instructions, it will be created in your home directory in a D2 folder, and you won't have all these files. I've just got them here. And this is going to be your primary interface into using the Donkey. So let me kind of go over this file in detail, and hopefully you'll get a better sense for what's here. Manage.py is actually a copy. If you have got a Donkey here, this is the main Donkey repo. There's a subdirectory Donkeycar. In here there's a templates, and there's a Donkey2, and you can see it looks a lot like manage.py because it is manage.py. This is just copied at the moment where you do the create car, the Donkey create car. When you do Donkey create car, let me move this to the center. When you use this command, this will create your manage directory, and that's actually just copying those templates to your D2, and that's putting it in kind of user space. So this is designed for you to edit, and Donkey is supposed to be kind of a library of parts that you use. So if you, just to go over that, if you look in that directory and you look in templates, you'll see that there's some other templates here. If you wanted to use this is the default config file. This is another template, this is a template, and this is a template. If you wanted to use any of these templates, you would need to add -- template, and then the name of the template without the .py extension, kind of like that. And then it would copy tk1.py into manage.py. And if you did that, your manage is going to look different. But if you do the default just like this, you're going to get a manage.py like we're looking at today. So we will look at that. But that's just explaining templates a little bit. So this is the D2 directory, and then this is the Donkey folder. I've got them both set up here so we can go back and forth. So I want to explain a couple things. So we'll look at manage, and I'll just go from top to bottom, try to give you an overview. If you look at this top line, it's a comment line. This is so Python ignores it, and it's got bang user bin end Python 3. And what this is doing, this is an optional line that's not technically necessary. So if you look at, if you do a ls, you can look at the attributes, and you can see that by default manage.py is read-only. But with this line, if you mark it as executable, doing something like this, now once you've done that, you can invoke it like this. Instead of saying Python manage, manage.py like that, you can invoke it directly without Python, and that makes it callable. So that's what that line is doing. This second block here is using this triple quotes to create a text block. These are options that are used by this module called docopt, which so these are not actually, docopt didn't invent this. This nomenclature existed first to give you an idea about how to document how this script should be used. And docopt turned these, it parses these options, and then we use it later on. At the bottom, I'm going to fold up this function and this function to make this a little bit smaller so we can see. It's going to, when you execute this script, it's going to define these two functions, and then the way we're invoking it, it's going to drop down to here. And this name equals main, this is a special block of code that only gets executed when you invoke this script as the first script. So if you were to write another script, like say the demo script, and then if you were to import manage, if you were to import this into another Python script, it would not execute this code right here. So this code right here, you can see the first thing it does is it does docopt with the doc string, and this under doc under is this text block here. And you can see it's got two kind of modes. There's a manage drive and a manage train. And you can see here in args that drive and train will only be true when it's passed in as an argument. So that's where it gets this argument. So this tells it that it's a non-optional argument. It has to be provided. This square brackets means this is an optional argument. So you don't, when you're driving, you do not have to supply a model argument. You do not have to supply this --js. This model, if you do supply it, it will be a pre-trained, a trained neural network model whose weights have been serialized into a file, and it will load that into TensorFlow right now by default. And then it will use that for predictions on steering and throttle if you choose to use that. And this --js turns some other so this turns some other flags on. So if you look at this --model and --js, you can come down to here and see how this once you parse this docopt, it creates a dictionary, and that dictionary has all the arguments, model and JS, and we pass those in as named arguments. We say, so first we load the config. This config right here comes from donkey load config, and you can see we're using dk dot here. This dk comes from the fact that when we've imported Donkeycar, we've aliased it with something shorter to type, but it does mean Donkeycar. So this Donkeycar namespace comes from when we do a pip install in this donkey directory. It will install this Donkeycar module into your wherever your virtual environment or wherever you're working. If you do a pip list, you'll see everything that you have installed, all the versions. So it's handy to check versions of things. And you'll see donkeys somewhere. Actually, I don't see it listed here. I don't see Donkeycar. That's funny. TensorFlow. That's funny. If I do a pip uninstall Donkeycar. Oh, I haven't installed it. Oh, I think I was uninstalling and installing it. So we can go through, if you don't have it, which you probably already do a pip install. So when you do that pip install E like that, it's worth noting that it installs Donkey as a reference. And so what that means is that if you go and you edit any of the files in Donkeycar that get used, you do not have to then go reinstall. If you just run things again, you will have those changes. Except if you go into templates and you modify that template, that is not automatically going to update your manage.py. In order to get that edit, you're going to have to run that donkey create car again and to overwrite your files. One thing you can do, if I do uninstall Donkeycar, just to show you, when you do an uninstall, it's going to show you what files it would remove. And you can see when it uninstalls that it's only uninstalling some links here. It's not installing a bunch of files. So this kind of shows that all with that pip install -e that it's just install a reference. So getting back to manage, you can see that so we know if we want to add more arguments that are optional, we need a square bracket, and so actually this is not used anymore, but it's still there. So this nomenclature means the model is required for training. You have to tell it what model you're going to write out. You don't have to tell it what tubs to use. These are this is telling you that you can comma separate them. Alright, so let's get into kind of another overview of what this is doing. So as it's doing this, parsing these options, it's calling one of two functions. It's calling this drive function or this train, and that's based on we check these arguments and then we call this function or we call this function. And we read in this config that we've read. That's this config file. That's where this gets loaded. And if you want to add anything else to the config that's not a part of the standard, you can just come in here and anything you type in here you could type something like my flag equals whatever. And then in manage.py, you would be able to somewhere when you're using it, you'll get passed in this config, which gets parsed, and then you can print config. What do we call that? My flag. My flag, and then that would print whatever happened to be there, or so if you're going to add some more things and perhaps it's a setting that you don't want it be in manage, you can put it in the config and it'll get loaded for you. Alright, so that gets passed in as this config. You can see this function has named arguments, and these named arguments have default values. That's what this equals none and equals false. So if you were to call this function and not pass in anything, then the model path would have this value and joystick would have this value. But we pass in these based on arguments. So if you don't supply an argument, then use joystick will be none. And if you don't supply a model path will be none. So let's dive into the vehicle. So we recognize this from last time. Here we're making our main vehicle, and this is where this is our container. This is our, I don't want to say container. This is the class that manages pulling every part, the run loop, the run of every part, and it also manages a memory class that it uses to matched named inputs and outputs. So the second thing we do here is we instantiate a PICamera. This PICamera this name comes from this line here, from Donkeycar parts camera import PICamera. This path right here, Donkeycar parts camera, is also telling you where the .py file is that has this PICamera. So if you look in Donkeycar, there's a parts subdirectory that corresponds directly to Donkeycar parts, and then this camera is no longer a directory, this is a file. And if we click on this file, we can see that it's got some classes in it. It's got a couple things here. And so this is where we get the PICamera name. You can see there's other kind of cameras here. So this PICamera is a class that manages some Pi specific camera, the ribbon camera, the serial camera that you can get. There are other kinds of cameras. You can get a USB camera, and then you can see that when we have this web camera that it uses the PIGame module, and specifically the camera part of that PIGame module, in order to access a USB camera. So if you're perhaps doing stereo camera or something like that, where you need to plug in two USB cameras, or if you don't have this PICamera, or you're on another platform that's not Pi based, then you might find yourself wanting to use this webcam. If you did need to use this webcam, you could go back to manage, and you could either remove this if you're not on a Pi, or you can put a comma webcam, and then now this webcam would be available to use right here. You could say cam equals webcam, and then you can have that. You can see in the camera we also have a mock camera. This is something that I use when I'm testing code on a machine that has no camera, but I don't want to change everything in manage. I just want to change it to a mock camera, and this is a little more useful than a mock camera. What this will do, this image list camera will scoop up a bunch of JPEG files and pretend that those are the images of a camera. So if you're testing some image manipulation in manage, you can add that image list camera, import it here, and you can say cam equals image list camera, and you can give it the path, or by default it will just go grab all the JPEGs, and then as you run in that run loop, it just it grabs all the images, and then one by one it loads the image and then returns that as the next valid image. Alright, so let's look a little bit more at PICamera. You can see that PICamera is given a resolution which comes from this config variable, that it is added to this v-add, adds the camera to the vehicle, to the part list. It has these named outputs, so this is the camera image. Again, this is an arbitrary string that exists only in this file. So as long as you name that consistently, you can see when you search for it, it's used 5 different places. So we use it here as an output, and you can see other parts use it as an input. Here, this is the pilot, that's the neural network train model. This uses the camera as an input. This is the tub data, saving that as part of its input. And then here we're back up to the camera. It's using that as an output. Here we see threaded is true, and that is our signal when we add it as a part to ask this vehicle to spin up a new thread to call this PICamera in a separate context, a separate thread context from the main context. So that will cause it to spin up this update in a separate thread, and in updating this, it just pulls the stream, the file stream, and it gets the frame, and then when run PICamera, where's run threaded? Run threaded is inherited from the base camera. So here's you can see PICamera, it's inheriting from base camera, and base camera defines run threaded. So by inheriting from it, we get this same run threaded. So you won't see run threaded here, but it's getting it here, and you can see by default it's returning whatever frame it has at the time when this gets pulled, and this gets pulled in the context of the main thread, where this keeps running as fast as it can. And then there's some cleanup here. So that's the PICamera. Next, we'll go on to the controller. So if you pass --JS, you'll get use joystick. Or if you don't want to pass that command flag, you can also modify your config file. If you do that, you get this joystick controller. This joystick controller class comes from Donkeycar parts controller, which you can see here. Donkeycar parts controller. You can get either local web or the joystick controller. So this defines a joystick, a physical joystick interface. This pulls the file dev input JS0 by default. You can supply a different one if you have multiple joysticks. And then I should have folded that. Yeah, I've actually rewritten this to be a little more concise. This is not ideal, but if you look at this update loop, this is what's actually pulling the joystick, and this is giving you which buttons get pressed, and then it's responding. Here's how the steering, here's the axis is going to come back as one of the analog values for on the stick, and then if it's the particular axis that we marked as a steering axis, it will multiply that whatever value is coming against a scalar, and then it's going to print it out for you, and this is the angle that's going to be used to steer. So you can look through this file if you want to see how that's done. And that gets used if you pass joystick as true. Here's a couple things that offer some scaling to this controller. You can look through the code and kind of see how these get used. These are kind of important if you're using a joystick. If you're not using a joystick, you're using the local web server. This is how that's getting added. So the controller right now is one or the other. This local controller, or this web controller, let me go to the top here and fold these classes. So you can, okay, so it looks like this is getting this Donkeycar parts web controller web. So this is going Donkeycar parts web controller web, and then here's where we're importing the local web controller. And so there's a little bit of indirection there. If you want to actually find the web controller, it's going to be in here. Here it is. You can see it's inheriting from a Tornado web app. So here's where it's getting the handlers for the different URLs, setting the directory path, and starting up the, here's the port that it's going to use, and it's going to start listen, which is going to be opening that socket for the web server to start listening for requests on. That's how that web server gets started there. And that web server has all of its data here and templates. So here's where we instantiate one or the other. One or the other. They both actually are designed to take the same inputs, and they both do the same outputs, and they're both threaded. So that's why we don't need to specialize this line. You get one or the other controller, and it takes this camera image, it outputs an angle and a throttle, and a mode, which is going to be user local or local angle, and a flag, which tells the tub whether it should be recording data or not. So next we're going to move on to a case where, I like that this is a simple case here. This is a Lambda part. The Lambda part basically just allows you to create a function that gets called as part of the part list. You can see we call this a pilot condition part. This Lambda takes a function name. This function is defined right above it conveniently. When we add it, because this function takes an argument, it needs to have an input. If you don't have inputs defined and you add this part, you're going to have problems, because Python's going to throw an error because it needs to have something as this mode. So to get this mode is coming from our controller part. So this has to use the same name as this, and then whatever mode is getting output, whatever variable type that is, it's going to come in right here, and it happens to be a string. And here we say if the string that was stored in this variable called mode is equal to user, then pilot, so this is telling us the purpose of this part is to turn on the AI pilot, the neural net pilot right now. So when the mode is user mode, then the pilot is not running. When it's anything else, so when it's local or local angle, we say yes, the pilot is running. So this outputs, so because we have a return here, we need to have an output, and we need to name it. And in this case, it outputs a Boolean, and the Boolean is named run pilot. And we'll see later on that here's our neural network that we've defined. This type is Keras categorical. If you look in the parts Keras, you can see that there's a base class. Here's the Keras categorical. When we instantiate it, if we don't supply a model via a name, it's going to do default categorical. And if you look at that, you can see here's where our convolutional layers are defined. Some of these settings, I'm not going to go over them right now. How we set up the different layers. Here's, I will go over this. This is the angle out. This is the steering. This dense means that it is a single layer of 15 neurons which is used to activate one of 15 possible steering angles. So it divides your steering, what you define the min and max range of your steering, into 15 bins. Odd because the center is 0. And then it does a soft max, which turns these floating point values that it comes into probability, and the neuron with the highest probability we say is our choice for which angle, and that's why it's categorical, and that's why that's where the name of this comes from. And the throttle is coming from a single neuron, which is a single floating point value, and this does some work to name our inputs and our outputs, and this selects an optimizer, and this tells us how we're going to define our loss. We're going to use on the output angle out, which we've named here, we're going to use a categorical cross entropy, which is an error term that you can look up that's useful when you have when you're using a category of to define what you mean by your accuracy. And throttle out here, we're going to use mean absolute error. So you can look and see what other options there are, but these are common defaults. There's no reason to modify these. This loss weight is weighting the error terms that come out of this with different values. So this is saying that the angle is very important and the throttle is less important when it's weighting to see how well the model is learning. And then this returns that model back to the parent, and that we keep a reference in Keras categorical. It keeps that reference to that model here, and that's how it loads and saves the model. So there's different model types here. Won't go over them all, but if you would like to try different, each of these has different properties. If this one takes an IMU, so if you decide you want to try out a different model type, you would want to instantiate a different model instead of Keras categorical. And there's some other changes that you would probably need to make too, but that's the primary one. If the model path is supplied, then we load it. So that makes the loading optional. So if you're just driving and you don't have a pre-trained model, it's going to skip that. Here we add that Keras pilot. It's taking an image as input and it's outputting an angle. This time it's not user angle, it's pilot angle. And instead of user throttle, it's pilot throttle. And you can see here this has a run condition. What this run condition will do is it will test this variable coming from this pilot condition. If this is outputting true, then it will allow this to run. If this is outputting false, it won't even attempt to. So if you never go to user mode, it won't even run this part. So you have a part that you don't want. Conditionally, you don't even want it to the run loop to be called. Although the fact that we've instantiated it as, well, we didn't instantiate it as threaded, so this run condition only really makes sense on parts that aren't threaded. Parts that are threaded, it will continue to run the update loop. It won't run the run threaded main thread context portion of that part. Hope that makes sense. Here we have another Lambda function. This is changing. This is controlling where we get the steering angle from. This is taking the mode And as it gets the mode, it also gets the angle and the throttle from the user, the angle and throttle from the pilot, and depending on the mode, it will return one or the other. In user mode, it returns whatever user and angle and throttle we had from our joystick controller, virtual or otherwise. In local angle, we get the angle from the pilot, but the user gets to supply throttle. This can be useful when you're validating a new model and you wish to stop when you can see that it's clearly going off the rails. Once you're more confident, you can switch to local mode, which isn't here explicitly, it's here as a bailout, and else. Here you can see we get pilot angle and pilot throttle. Now the AI is in complete control of the car. And this drive mode again is added as a Lambda part because we didn't really define it as a class. You could define it a new class with the run loop, with the run method, and then you can define that run method to be all of this. And this just makes it a little terse and then puts it in user space so it's a little less hidden what's going on. And you can come in, and if you have additional logic that you want to change when different angles get used, that puts it in your hands. Okay, everything above this, well, no, the camera was hardware related, but we're starting to get into things that would change from one robot to another. Kind of the point of this is for you to use this as a template, and if you have a robot that uses a different physical parts, that you're able to reuse most of the structure and then replace their steering controller with perhaps an H-bridge controller or something that you have. Here you can see the default is using this PCA 9685 part, which comes from this is the name of the chip that's used on the PWM board that outputs the PWM signals. And this is using the I2C interface to talk to the Pi. And then the Pi is sending signals telling it to output PWM outputs for the servos, different kinds of servo. Well, here this is a steering servo, and the ESC isn't a servo, but it takes the PWM output to control, to modulate it through its range of values. So you can look at the piece, you can find that. If you want, we can go back again here from Donkeycar parts actuator. So if you go look in the actuator, we can see this has all of our parts here. You can see there's some other stuff in here too. If you have a DC controller that's using this Adafruit, the Adafruit daughter board, which is quite easy to use, you might consider using that part. I don't know about this. I've seen these Pololu servo controllers, but here's where you could, if you had one of those. And there's some teensy stuff here that's using the serial to pull this. Not sure exactly everything that this is doing. Looks like IC set, headlight, set brake. So it looks like this is kind of using a teensy to replace some of the inputs and output controller that PWM board, the 9685 would do. And this mock controller is just something I put in when I'm running it on a PC or something that has it doesn't have any of this stuff on it because it's a PC. When I'm just testing it, I just change that to mock controller so that I have to change less code, or you can just comment out. That's the thing about these parts, is that you can just we could just say, well, I'm running it. I'm not running it on a robot. I'm just running it. So I don't want it to do any of this stuff right here. And just by doing that, now you can run it on a laptop or something if you need to check some code and you don't have your robot with you. So here you can see it's taking this controller, it's using this for a PWM steering part that maps this range of values to high and low. And here's a throttle that has a high, middle, and low pulse, and it maps those range. And so as this throttle gets called, it will send the PWM signals off to the board to control your motors, your servos, and your ESC. And here we add those two parts, the steering and the throttle part, to the vehicle list. Okay, getting close to the end here. Looks like these are the inputs for the tubs. We're getting the image. We're recording the user angle, user throttle, and user mode. And this types has to match, well, there has to be the same number of elements in this types array as there are inputs. So this, if you look in the storage type, you'll see where all these types are defined. This is a string value. So this is that user local angle. The throttle and the angle, these are going to be floats. And this is going to be the image, the JPEG that it's going to save out from your camera. This tub handler is given a path from your config file. This tub is a new tub, it instantiates a new tub writer. And it takes as inputs this list there, and then it won't run if the recording is false. So recording gets set from the output of the web controller or the joystick controller, controls whether or not you're recording, and that controls whether this tub is running or not. And finally, we have the main start to the run loop. We kind of took a look at that last time. That is going to fire up our parts and iterate over them in the order that we added them. So it'll do the camera first, then the controller, and it will do this tub handler last. So I hope that kind of makes sense. That's the main drive loop. I'm going to go over train a lot faster. This is something that you can research on your own. There's a lot of good resources for learning Keras and for learning training. The basic idea is this is a supervised mode. This is we give it, this is the initial conditions, and these are the targets that it's trying to output. So it's taking as input the camera image, and it's we're going to tell it to match these values that we've done, which come from these user angle, user throttle need to match whatever strings we've given it in this right here, wherever we've named in our tub directory, because those are going to get loaded as JSON objects when it's doing the recording. And you can see here we have to instantiate the same type of model that we used above. For the same type of pilot Keras part, we're using categorical, and this categorical takes whatever angle. This is going to be a continuous angle, and it calls this util function linear bin to bin this into 15 different possible. It does a one-hot encoding. So if your angle was 0, then you would be right in the middle. So it might be index 7. And so it'll be 15 zeros, but the 7th zero will be 1. And that will be stored. It looks like it writes over the So this record is a dictionary. It takes the previous value, which was a float, and then turns it into a one-hot encoded, and then returns that modified record. And you can't really, it's not really clear where this function is called, but this RT gets passed in is short for record transform. So as each record gets loaded, this is an optional argument. If that's applied, we have the opportunity to do some processing on the records that they're stored on disk before it goes to the neural network to train. And here's just some basic stuff. It's doing to, if you don't supply tubs, it gets all the tubs, creates a tub group. If you do supply tubs, then it will use whatever you passed in to make a tub group. And this makes some generators that will load all your records off disk as they're required from the training functions in Keras and TensorFlow. And here's just a little bit of record keeping to look at how many records you've got and split them into a training and validation set and let you know what that split comes out to. And then here's where we call train, and this is going to output the train model to whatever model path you've passed in. So I hope that helps a little bit, gives you, knows a lot of information to take in. You might have to watch it a couple of times if it's all new to you, but there it is. If you have any questions, just leave it in the comment section below. Thanks.